Good morning to all. So last topic is in second module, that is geodetic surveying, and also what is we have to study in this only triangulation system. First we have to see geodetic definitions. Surveying techniques to determine a relative position widely spaced points, length and directions which require the consideration of the size and shape of the earth. Okay, there are two methods of the geodetic surveying. First one is triangulation system and second one is precise traversing. Okay, in your syllabus only mentioned triangulation system, and also you people have to study triangulation system. So we will see definition of the triangulation system, or else meaning of the triangulation system. The process of a measuring system comprised of a joined or a connected triangles whose vertices are a station marked on the surface of the earth, and in which angular observations are supported by occasional distance and astronomical observation is known as the triangulation system. Consider figure 1 and figure 2. In these cases there are three boxes and also it is connected by a triangles. That is nothing but the triangulation system. Okay, some principles having a triangulation system. First one is entire area to be surveyed is converted into framework of the triangles. See here, in this case figure 1, we will survey entire area and it will make like as a framework of the triangles. Second point is, if the length of and bearing one side and the three angles of a triangles are measured precisely, the length and direction of other two sides can be computed. Third principle is, precisely measured line is called baseline. Initially what we measured, that line is called as baseline. Computed two lines are used to baselines for two interconnected triangles. If you making the triangles, first we have to take a one line and 2 points. By using of these 2 points and one line, we will get the triangulation system. Okay, so next one is, vertices of the individual triangles are known as a triangulation system. As said right now only, vertices of the individual triangles is called as a triangulation system. Okay, next one is, extending this process network of a triangles can be computed over entire area. By using of this triangulation, by using of this small triangles, we will surveying to whole area. Okay, by using of triangulation system. As a check, the length of one side last triangles is also measured compared with the computed ones. Okay, and last one is, astronomical observations are made at an intermediate station to control the errors in azimuth. And triangulations are classification, or else classification of a triangulation system or order of triangulation system. In this case there are three classification of triangulation system. That is nothing but the primary or first order triangulation system, secondary or second order triangulation system, tertiary or third order triangulation system. In primary, what will happens, highest grade triangulation system to determine the shape and size of the earth surface, or for providing precise planimetric control points for a subsidiary triangulation. In these cases, stations are generally selected up to 16 km to 150 km apart, and some specification in primary triangulation. That specifications is, first, previously length of the baseline is up to 8 km to 12 km, and length of the sides is 16 km to 150 km, and average triangulation or triangulation error is less than 1 second maximum station closure is less than 3 seconds. Actual error of the base 1 is to 50,000, and degree of accuracy like this, and discrepancy between two measures is 5 root of kilometer. First we have to prepare these all specification, and also you people have to remember these specification. Okay, must and should they will ask in question. And secondary system. So in secondary system, it is to connect two primary triangulations to provide a control points closer together than those of primary triangulation. Within the primary triangles, other points are fixed at a closer interval so as to form a secondary series triangles which are tied to the primary system at intervals. In work of this nature, comparatively smaller triangles are used. The instrument and methods used are not of the same utmost refinement. The average triangles closer 3 seconds and the maximum. Okay, see, in secondary or a second order, first basically they will find one single triangle by using of that primary triangle. Again, by using of that base triangle, they will find one more triangles, and also by using of these all triangles, by finding of these all triangles, they will cover entire area. And some specification of a secondary triangulation system. See here, some specifications are there. Length is 2 km to 5 km. Length of this side is triangles is 8 km to 70 km. Same like that you people study. Okay, and tertiary or third order triangulation system. In these cases, within the secondary triangles, what we studied in secondary triangles, no, so within the secondary triangles, points are established at a shorter intervals to furnish horizontal control detail surveys. In these cases, triangles are still small, and at 12 cm to 20 cm instruments are used to provide a control points between a station of a primary and a secondary order triangulation for the justification of a horizontal control for a topographical surveys on a various scales. So this is also having a some specification. After that, triangulation figures. See here, basic triangulation figures are: first one is triangle based quadrilateral polygon with a central station. So I will explain about first one, triangle. See here, first we have to mark first node, and also we will get the second point. By using of these nodes, we will draw we will get the baseline. Okay, by using of these three datas, we will forming a triangles. Okay, in these cases it is a triangulation. Same procedure in based quadrilateral. Okay, in these cases, first we have to select point 1, point 2, and we will get the baseline. By using of the baseline, we will forming a triangle. By using of this triangle, again we will forming one more triangle. Again same things, and these quadrilateral or triangles covers the entire area. That is nothing but the triangulation system. By using of triangles, we will survey the whole area. That is nothing but the triangulation system. Okay. So after that, polygon with a central station. There are so many of the polypoints and also so many of the polytriangles. By using of these all, we will get the triangulation system, and also we will cover the entire survey, entire area. Okay, so after that, second one is single chain triangles and double chain of triangles. Okay, see here, in single chain, figure is used where a narrow strip terrain is used to be covered. Though the system is a rapid and economical, it is not accurate for a primary work since the number of conditions to be fulfilled in the figure adjustment is relatively small. Also, it is not possible to carry the solution of a triangle through the figures by two independent routes if the accumulations of errors is not become excessive. Baseline must be introduced frequently. So by using of only single chain, we will measure the area, and also it is a single line. In these cases, see here. So in these cases, and also double chain method, it is a covers entire area, and also double row of triangles is having in double chain method. In single chain, only single rows having. Okay. Next one is based quadrilaterals. Okay, see here. First, filled triangle is nothing but the fixed station, and empty triangle is triangular stations, and double line is measured baseline. AZ is fixed azimuth. So here, in these cases, the quadrilateral with the four corner stations and observed diagonal forms. See here, observe diagonal forms and four quadrants, and in these cases cover triangles. See here is cover triangles. By using of the, we will get the one entire box. After that, by using of this box, we will start the next one. Same part next and same part next. In this case, intermediate will form some triangles. Okay. So they are best suited for a hilly country since the computed lines of the sides can be carried through the station by different combinations of sides and angles. The system is most accurate. Okay. Next one is see, this is next one is center triangles and polygons and grid iron system. This system, it is a primary or a first order triangulation system. This is covers the entire area, and also it is covers a large area. So, and by using of polygons with the central triangles and also suited to uneven surfaces. Okay, it is first one. In these cases, it is a grid iron system. In this case, what will happens? It is comes in a primary triangulation system. These both are comes in triangulation primary. Sorry. This and this one is comes in primary triangulations. So in these cases, what will happens? It is comes in a primary triangulation system. The area enclosed are the covered with a network system. It is known as a grid iron system. In these cases, entire area covers by triangulation, and in intermediate or a central, they are having a one triangle is forming, that is nothing but the central system, and also it is covers a large area, that is nothing but the primary triangulation system. Okay, so after that, next point is selection of baseline. So in this cases, selection of baseline, already I told to you what we start surveying, or else what we start a triangulation system. No, initially 2 points and initially one baseline, it is called as a baseline. So in that cases, what is we studied baseline, and also how we will select the baseline. So that baseline should be fairly level at site. The side should be free from observation. The ground should be firm, smooth. The two extremities of the baseline should be intervisible. The size should be such that well conditioned triangles can be obtained. The size should be such that minimum length of the baseline as possible. What we specified in specification now, that much having some ranges is available. And next point is selection of triangulation system. In these cases, triangulation of system, the triangulation system should be intervisible. For this purpose, they should be placed upon the most elevated ground so that a long sight throughout the undisturbed atmosphere may be secured. They should be form well shaped triangles. As for possible, triangles should be either isosceles base triangles, it is in the degree of 56 degree, or equilateral. Minimum triangles having a 30 degree, and also it is not exceed 120 degree. The station should be easily accessible and should be such that the supplies of food and water easily available and companying and or nearest suitable accommodation is available. The station should be situated so that the lines of sight should not passes over towns, factories, furnace, like any obstructions. Okay, next point is station mark. In station mark, how we will mark the station? So in these cases, the mark should be distinctive. The mark should be distinctive and interdestructive. Okay, two marks should be provided, one visible on the surfaces and the other buried vertical below. The mark may be set on a firm rock or on a concrete monument. We have to mark a station, one firm rock or else concrete monument. Two or three references marks similar in the materials and the shape to the station mark should be installed. The distance and bearing of these references mark from the station mark from the each other should be recorded on them. Okay, we will have to record the stations. At each station where a tall signal towers is needed, and an azimuth mark should be established at some distances away from the station mark. The azimuth mark should be of the same size and the character of as a reference mark. Second point is selection of site, selection of a site for a selection. Okay, site selection. The site should be fairly level, and also the site should be free from obstruction throughout the whole length. The extremities of the base should be intervisible at a ground level. The ground should be reasonably firm and smooth. The water gaps will be formed at a possible not wider than the length of the long wire tapes. After that, we have to study, and also having one last topic is that is reduction to center. See here, reduction to center means okay. Already we know the points, no, baseline and base points we will know. So by using of these points we will get the triangulation system. So by using of these all, we have to reduce the reduction of the center. So how will reduction of the center? How will do reduction of the center? See here, when the observation are taken from such a station, it is impossible to set up an instrument over it. Okay, if it is one station is there, in that cases, if we observe that is a station, that station is center, in that cases it is our instrument have impossible to set up on that point, or else maybe inconvenient purpose. So two observations are taken to the other triangulation system with the precision as should be have been used in the measurement of the angles through station. Satellite station should be avoided. Satellite station should be avoided as far as possible in primary triangulation system. The distance between two station and a satellite station is determined by either by trigonometric leveling or by triangulation method. The operation of a corrections due to eccentricity of the station is generally known as a reduction of the center. By using of the eccentricity of the station, we will also have to reduction the center. These angles are later corrected and reduced to what they would have been if the true stations was occupied. If the true station is occupied, the angles some angles errors and reduces, and we have to reduces the some centers. By using of these all points, we will reduce the center. Okay, this second modular is completed, and tomorrow onwards I will take the third modular.